Alright, section 4.4 is where we start to make these triangle proofs a little easier. We're going to be using something called SSS and SAS. The objective is to apply SSS and SAS to construct triangles and solve problems. Prove triangles congruent by using SSS, SAS. Alright, what these S's and A's stand for: S stands for side, A stands for angle. So we are going to prove, instead of last section we used all three sides and all three angles in order to prove the two triangles are congruent. So we used a total of 6 pieces of information. Now we're just going to use these 3 or these 3, either the 3 S's or the 2 S's and an A. And you'll see how that kind of makes it a lot easier. So we're only proving 3 sets of information instead of all 6. Alright, so triangle rigidity and included angle vocabulary. In lesson 4.3, you prove triangles are congruent by showing that all 6 pairs of corresponding parts were congruent. That's what I just said. The property of triangle rigidity gives you a shortcut for proving 2 triangles are congruent. It states that if the side lengths of a triangle are given, then the triangle can only have one shape. So triangle rigidity is your first buzzword. So for example, you only need to know that the 2 triangles have 3 pairs of congruent corresponding sides. This can be expressed as the following postulate. So we are going to call this SSS. So look at these 2 triangles and draw these with the same measurements on them. So this has 4 centimeters and 4 centimeters. 6 centimeters, 6 centimeters, 7 centimeters, 7 centimeters. So since they have the 3 sides in common, we can go ahead and conclude that they're congruent. We don't even have to worry about the angles. This SSS postulate says that we don't have to worry about the angles. Alright, so adjacent triangles share a side, so you can apply reflexive property to get a pair of congruent parts. So what this is saying is if a diagram looks like this, we can use the fact that DB is a line to both this triangle and this triangle. So let's pretend B is the midpoint of AC, so that means these would be congruent, and somebody told us that AD was congruent to DC. Then we know DB is equal to DB, so we can put this here as well. And we would say DB equals DB, and then our reasoning would be reflexive. So here's where we use the reflexive. Alright, so use SSS to explain why triangle ABC is congruent to triangle CDA. So let's do a little proofing. So I'm going to go ahead and nothing's really given to us except for the diagram. So the diagram, the information in the diagram, I'm going to go ahead and just put into our given. When we finally use proofs, it will say in the given spot, it will say given AD is congruent to BC and DC is congruent to AB. But since it doesn't, I'm just going to go ahead and put AD equals BC and AB equals DC, and that is all given. It's a given based on the diagram. It's not said given like we've seen, but in this diagram it's given. Alright, then I'm going to use the fact that AC equals AC. That's reflexive. So I'm going to basically just put this side of the proof, this side of the equal sign will be, then I should probably switch that. I'm going to do this side of the equal sign is triangle 1, and this will be triangle 2. So I'll say AD is equal to BC, and DC is equal to AB. So notice how I've got my equal signs lined up. I've got, this is all of my triangle 1 information. I've got my 2 tick marks for AD, my 1 tick mark on DC, and then this is the line AC for this triangle. Now over here I've got BC, the 2 tick mark, AB, the 1 tick mark, and AC, the reflexive. Alright, so basically once you've gotten that, you've been given a side, and a side, you can go ahead and say triangle ABC is congruent to triangle CDA by side, side, side. That's side, side, side is going to be your reason, your postulate. Alright, what this is trying to say is an included angle is an angle formed by two adjacent sides of a polygon. So, for your notes, go ahead and write down your second buzzword is included angle. Included angle. So, angle B is included between side AB and side CB. This is going to be important for side angle side because they have to be included. It has to go side angle side. So angle B is included between these two angles. It's basically what sides make up the angle, and that's what they're included between. Alright. It can also be shown that only two pairs of congruent corresponding sides are needed to prove the congruence of triangles if the included angles are also congruent. So this is why the included angle was necessary for you to know. Because this is the included angle and this is the included angle. So when you go side, angle, side, and you've matched up side, angle, side, you can say that they're congruent. So notice how it's included between the blue and the green line. They're not saying the angle's over here, because that would be side, angle, skip a side, and that's not the postulate. It's side, angle, side. It has to be in between the two sides. So read left to right, you go side, angle, side. So side, angle, side. It has to have the angle in between the two sides. Alright, the letters SAS are written in order because the congruent angles must be between the pairs of congruent corresponding sides. So again, this is kind of just a reminder of how you should be writing the problem. So since it's side, angle, side, you should go, kind of like connect the dots, a side to an angle directly to another side. Alright, the SAS postulate guarantees that if you are given the lengths of two sides and the measure of the included angle, you can construct one and only one triangle, which that's cool to know. Alright, so let's prove this. This is supposed to say a line above BC, a line above AD, and this is supposed to be the congruent sign there. So given BC parallel to AD, BC is congruent to AD. Again, that is marked for us in the diagram. How nice of them. Alright. So again, we've got BC parallel to AD. Again, this sideways L's mean parallel. And we've got BC congruent to AD. And that's given. Alright, what you need to always do is find the reflexive side. So notice in this diagram, this BD is a part of both triangles. So I can say that BD is congruent to BD because of reflexive. If I can write. Alright. Now we need to find whether we can use side, side, side or side, angle, side. And they don't tell us these sides over here, so we probably can't use that. But we do know that these two angles these two lines are parallel. Because these lines are parallel, we know there's some angles in this that are congruent. So that's what you have to look for, is when you have parallel lines, you have to look for the congruent angles. So I'm going to trace out these parallel lines and see if we can find out which angles are congruent. So if I start here, trace out this angle, trace out this angle. This is the letter backwards Z, and the backwards Z is alternate interior angles. So because of alternate interior angles, I know that CBD, is congruent to BDA. Because they're parallel, it has to be. Make that a little bigger. Alright, so this is congruent to this. So now I just say in my proof, angle CBD is congruent to angle BDA. and that's because of alternate interior angles. Now I've proven a side up here, a side right here, and an angle right here. So I've got enough, and look how the order is. I go side, angle, side, side, angle, side. So the order is good. I go in order. The included angle is the angle that I'm measuring. So now I can say, again, everything that always goes in your bottom left box is what you're asked to prove. So triangle ABD is congruent to triangle CDB because of side, angle, side. That's it.